Welcome back. Today our topic is: what would happen if Earth fell into a black hole? What would happen if a black hole appeared out of nowhere next to Earth? But before that, make sure to subscribe and hit the bell icon. Let's find out. Mass, charge, spin. There are three properties of a black hole that are measurable: their mass, their spin, and their overall electronic charge. Indeed, these are the only three parameters that an outside observer can ever know about, since all other information about anything that goes into making up a black hole is lost. This is known as the no-hair theorem. Put simply, no matter how hairy or complex an object you throw into a black hole, it will get reduced down, or shaved, to its mass, charge, and spin. Of these parameters, mass is arguably the most significant. The very definition of a black hole is that it has its mass concentrated into a vanishingly small volume, the singularity. And it is the mass of the black hole, and the huge gravitational forces that its mass generates, which does the damage to nearby objects. Space spaghetti. One of the best known effects of a nearby black hole has the imaginative title of spaghettification. In brief, if you stay too close to a black hole, then you will stretch out, just like spaghetti. This effect is caused due to a gravitation gradient across your body. Imagine that you are headed feet first towards a black hole. Since your feet are physically closer to the black hole, they will feel a stronger gravitation pull towards it than your head will. Worse than that, your arms, by virtue of the fact that they're not at the center of your body, will be attracted in a slightly different direction than your head is. This will cause parts of the body toward the edges to be brought inwards. The net result is not only an elongation of the body overall, but also a thinning out, or compression, in the middle. Hence, your body or any other object, such as Earth, will start to resemble spaghetti long before it hits the center of the black hole. The exact point at which these forces become too much to bear will depend critically on the mass of a black hole. For an ordinary black hole that has been produced by the collapse of a high-mass star, this could be several hundred kilometers away from the event horizon, the point beyond which no information can escape a black hole. Yet for a supermassive black hole, such as the one thought to reside at the center of our galaxy, an object could readily sink below the event horizon before becoming spaghetti, at a distance of many tens of thousands of kilometers from its center. For a distant observer outside the event horizon of the black hole, it would appear that we progressively slow down and then fade away over time. Bad news for Earth. What would happen, hypothetically, if a black hole appeared out of nowhere next to Earth? The same gravitational effects that produced spaghettification would start to take effect here. The edge of the Earth closest to the black hole would feel a much stronger force than the far side. As such, the doom of the entire planet would be at hand. We would be pulled apart. Equally, we might not even notice if a truly supermassive black hole swallowed us below its event horizon, as everything would appear as it once was, at least for a small period of time. In this case, it could be some time before disaster struck. But don't lose too much sleep. We'd have to be unfortunate to hit a black hole in the first place, and we might live on holographically after the crunch anyway. Mind the radiation. Interestingly, black holes are not necessarily black. Objects at the hearts of distant galaxies powered by black holes are supremely bright. They can readily outshine the rest of their host galaxy combined. Such radiation is generated when the black hole is feasting on new material. To be clear, this material is still outside the event horizon, which is why we can still see it. Below the event horizon is where nothing, not even light, can escape. As all the matter piles up from the feast, it will glow. It is this glow that is seen when observers look at quasars. But this is a problem for anything orbiting, or near, a black hole, as it is very hot indeed. Long before we would be spaghettified, the sheer power of this radiation would fry us. Thanks for watching, goodbye.